So TypeScript. Before I actually, OK, TypeScript. So you already know me, hopefully. Software engineer here at Google and Firebase. I work on the Firebase console. So if you're using Firebase, who's using Firebase? Great. That's your most favorite serverless platform, right? Yeah, NgRx core team member. And this is a good question, because this is entire day was somewhat NgRx or state management themed. Who's using NgRx? OK, good, good. A lot of you. Good. I write for Angular in depth, although a little bit less right now, and review there. I used to review a lot of articles there as well. And I added this recently for the Poland now, since I'm organizing this a second time. So organizer of AngularToronto. So again, please follow on Twitter. You use Twitter as well, by the way. There's a lot of interesting things happening on Twitter, a lot of discussions, too, about the web development in general, be it Angular, React, Vue, or any others as well. So that's that. OK. So who's following all the latest TypeScript releases? Great, great. No, that's not a lot, but some. So I was really excited. Was it 3.7 was released in November, so just over a month ago. And one of the cool things that are brought to us is optional chaining. Optional chaining, something that was available for our Angular templates in a while. You know, there's that question mark operator when they have a deeply nested object. You're trying to get to the deeper property, right? But a lot of them could be undefined on the way. So you have to usually do, object.property and property.another property, trying to get to the deeper one. So Angular templates already for a while had this question mark. So it's like, hey, you can, if it's undefined, sure, just stop there, right? So TypeScript now got it as well, which is great news. And I think I've heard actually just last week, JavaScript is trying to push optional chaining to the stage 4, which is really like implemented. I might be wrong there, but so don't quote me on that. But they're close as well. Anyhow, that was the release. Who's already on 3.7? One. I'm not talking about personal projects. OK, I just started fresh new. OK, 3.7. Your real project. OK, yeah. Yeah, that's what I thought. Anyhow, you can use that fantastic optional chaining when you move to the 3.7 in a few years or so. OK, great. So let's talk about some of the features. We'll start building from something that you're most likely familiar with, and then we'll build up into more advanced and then more advanced ones. We'll start with generics. We'll cover some of the union and intersection types, conditional types, which is a great thing that already starts, not a lot of people use them. And then we'll get into more like type inferences. Why do you need all of that to begin with, right? You need it so you can, as an author of library or service or any of your code, can really fine-tune how your user, which is your other developer or yourself, would be using your piece of code. So this is really important for that fine-tuning. JavaScript is really, really dynamic language, and we'll see some of the crazy examples today. And TypeScript is able to bring some logic to that dynamic mass. OK, so let's start with generics. Say we have a function, and we want to compare two things, A and B. And A and B are like strings. And we'll return the number when we compare them. That works great. But now we want to compare not only strings, we want to compare numbers as well. Well, there's multiple ways you can do it. One of them is function override. So you say, OK, you have one function that will be comparing strings. I have the other function that will be comparing numbers. And then you have to have a general implementation for both of them. You can do string or number there, but you can do just any. Obviously, that leads to a lot of problems because TypeScript goes, for example, you pass string and number. Right? Let's check string and string. OK, I don't know about that. No. Number, not that. Any and any. Oh, I got it. And you obviously get some kind of like runtime error or something like that, or unexpected results. So there's a better way to compare objects of the same type. And this is where generics come in. So T, right, you say A is of type of T, B is of the same type of T, regardless if it's a string or a number. And you just put a generic in front of the function, right? So this is how you would write a simple generic. You don't have those T's, that A, B does not have to be a specific T, specific type. It could be a more complicated type. For example, here's an array, which is, I don't know, it's not that complicated, but still, it could be just a symbol that could be shared between A and B. So here we can be comparing, for example, arrays. You can do even further. You can specify another type, for example, like here, U, which extends T, right? So it will be a subtype of T. And you can set the dependencies this way. It's like a general function, which have T, A would be of T, and B will be of type U, but U has to extend type T. Okay? So you sort of build on generics. So you can set those dependencies between those types. All right, so this is generics. Next one is unions and intersections. And they seem to be like quite straightforward. However, there's some surprises there. For example, we can say this is how you write the union, A or B. You could do type C. And if you try to intersect them with A ampersand and B. What's interesting about that, and actually caught me off guard when I first started using it, which was kind of intuitive, what happens with the properties of those types A and B? This is the slide that TypeScript team sort of provided while they're trying to explain that in one of the Stack Overflow bugs. But say, for example, we have four sets. So we have blue things, we have red things, we have big things and small things. All right, so when we intersect the type blue and small, we actually create a new set that has the union of the properties, right? So we're intersecting the types, but their properties would be union. So when we intersect blue things and small things, that subset would actually have both properties of small and blue, right? Because this is really a subset of those. So we're intersecting types, but properties are united. And then if we union, like for example, blue and red things, we get a new set. But the properties of that subset would have an empty, because there's literally no intersection there. So red or blue would be empty set of properties. This could be surprising, but it actually makes sense, hopefully, after this one. OK, so next one. Conditional types. Who's using conditional types? I've heard of them. OK, good. So we can build off types depending on what other types are. So for example, if we can say if T extends U, right, check it. Then we can return types X, otherwise type Y. Let's see the actual example of it. Diff. So if we're building a more complicated type, which we'll call diff of T and U. So we remove types from T that are assignable to U. So we check, OK, does T extend U? If it extends U, we'll return a special type called never, which means it just eliminates those. However, if T extends U, we'll return those T back. That creates like a subset of that. We can remove some of the types. So for example, we have, as a T, we'll have a string or number type. Like it's a complicated type. And we want to diff them by string. That way, we would get only the numbers back. So this way, we can just extract numbers. Okay, so if we do diff of that complicated type by string, we can remove something that's not strings, which are numbers. We can do it the opposite way and create the filter. So you just flip that never and T around. And if it extends U, now we'll return that T. Otherwise, we'll return never. And this way, it acts as a filter from a more complicated type. So for example, if we want to filter from complicated types something that's assignable to strings, we will use this filter, right? Does it make sense? Right? Good. OK. There are some built-in types already. For example, there is a special non-nullable type. It's a built-in type, and it acts as a difference, right? So from T, we're extracting everything that's not assignable to null or undefined. So what it means, after this, we're guaranteeing that T is neither null or undefined, and it's some other type that could have those. When I was actually working on this, I used it a lot, but I noticed that in the wild, outside of Google, for example, it was less used. And I was like, why? Why? It's just such a critical type, right? And then I discovered that apparently not everybody is using compiler option strict true, which is setting the TypeScript to the strictest mode. Who has that? All right. For the rest of you, you have your homework for today. You get home, you get into your project, you put strict true right away, and really fix your code after that. Good luck with that. Yeah. So you might be busy night. TypeScript is your friend. Let's use all of its powers. Let it have the strict mode true. One of the things that's, if it's false, for example, it allows you to swallow all those nulls and undefines, right? You can assign specific type. It's like, OK, if you say so, it is so. Then strict mode of TypeScript won't allow you to do that. At Google's code base, this is a default, and we cannot even turn it off, right? So use it. Let TypeScript be your real friend. So where this non-nullable becomes handy. So for example, there's a filter operator over ArcGIS. And as it was currently, as it is typed pre 6.5 release that it just had, it wasn't realizing that here. So we, for example, compare ID rating. ID rating none equals to null means we filter all the values that are, would be null, right? So in theory, if we use this operator in our operator chain, it should know that ID rating, for example, can no longer be null or undefined. However, in the previous version of RxJS, they weren't typing that, so they weren't using that. So we had to type it ourselves and help this filter function. So what do? Well, we would say we'll use it sort of like a type guard and saying that after this function is run, we'll specify the return type of this function, right? We'll specify that ID rating is non-nullable of whatever ID type was before. So here ID rating could be primitive. It could be like maybe number. We could have said ID rating is number after this. But if ID rating is a more complicated type that you need to import and all that stuff, sometimes you don't want to do this. You say whatever the type of ID rating is, after this function, it can no longer be null, right, or undefined. So this is how we would use it. It's a pretty cool thing, and we use it quite a lot. OK, and there are a number of other conditional types that are already built in from, I think, TypeScript like version 2.8. So this has already been for a while. Exclude, extract. Again, this is non-nullable. Return type of the function. You can just extract the return type. Instance type. So those are all great. OK, next. So we now know what the conditional types are, but we can go even deeper. What if we want to find out what's the, for example, type of an array is, of what it's an array of? Well, we can infer that, and we can extract that. If, for example, if T extends an array of U, whatever U is, there's a special keyword of infer. So we'll go and infer that U and return that U. Otherwise, we'll just return never. How does it work? All right, so for example, we'll get a function of type, right? Get type. And we'll have this array type that returns. So we'll now pass in an array. Let's see what, here it is. Say we have an array of strings, like ABC. Now, we'll use that function and pass it in. And let's see what TypeScript how it helps us. It unpacks that array and tells us that it would return a type of string, right? So it's an array of string. It unpacks that array and says, OK, that's a string that you want. Pretty cool, huh? It's not only, it can do more. It's not only just arrays it can unpack objects for specific properties. And we'll see how in a minute. All right, so that was a lot of information, right? Let's sort of get it together, how it sort of came and how I got to this topic to begin with. So I just got back from Ukraine and Poland, where I had a few meetups and conferences. But one of the things I wanted to have a fresh, brand new talk for that. Well, was actually one of the conditions. I was invited in one of them. And I was thinking, what should I come up with? What kind of interesting topic can I talk about? And again, on Twitter, where else? I see somebody's mentioning me. And that was Lance. He's from Angular Bootcamp. It's probably one of the most advanced Angular popular in US courses for Angular. And he was digging or using the new NgRx version 8 at that time. And something caught his eye. And that something was the createAffect function. He was really surprised how, based on one of the arguments, which was an object, based one of the properties of that object, the function was behaving completely differently. And he was like, what is it? And that's what he wrote. Wants to be something who understands generic typing of this function. This is a really great thing. So Lance started digging deeper into the function in the source code, which is a great thing, by the way. It's really great quality when you are, stumbling upon something and then you are, trying to understand how it works underneath. It's a great quality that will help you really advance your career. But anyhow, he was digging through that and stumbled on that. And we'll unpack in that create function in a second. But first, let's try to see what kind of problem we were solving with this createAffect function. Well, before NgRx version 8, we were decorating our effects with the effect decorator. And for example, here, it's a property, right? And that property, we assign something like actions of pipe. And this is basically observable of action. It needs to return us observable of action. But if you're not specifying it right now, right, how do you know? So one of the things that I'll keep on telling every time, again and again and again, is that you need to specify the property of this, the type of this property, to be observable of action. If you don't specify, compiler doesn't help you. And what do you get? You get an error at the runtime. So let's catch it sooner. So one of the options is, yes, observable of action is one of the things. And the second condition, it could be also observable of unknown. If we set a special, pass in a special object, which is effect config, we pass dispatch false in effect there, in the decorator. We don't care what observable of that is. It doesn't have to be action, because we are not dispatching it ourselves. It could be it just has to be observable of anything. So now we have two different situations based on a specific config, which is like a dispatch. However, again, property decorators are not type safe. They cannot enforce the type of that property. So there's no way to enforce that. And we were getting those errors at runtime. OK, so here comes the function. functions can actually enforce a specific type. And this is how our create effect was replacing the effect decorator. So the basic signature, we would say, OK, if, so it will take two things. First is our action pipe, action.pipe, whatever, observable, which is R there. And second, it takes the options argument, which takes that config of the effect. So if options is past the dispatch with false, we want our R, which is a return type, extend the observable of unknown. So it could be just observable of anything. By the way, unknown is also a special type that can, anything can be assigned to the unknown, but nothing can be retrieved back. OK. So then we can have another function override. And this is where dispatch is true. So if a second argument is dispatch true, we need to return observable of t, and t needs to extend the action. So this is combining two. Then we need to have a basic implementation for both of those. And this is actually oversimplified version because there was like 5 function overrides. And I thought about it as like, OK, we can use the new TypeScript features and do it a little bit in a cleaner fashion. So this is where I got into this and changed it. OK, but first, we have this effect config, right, that could have this dispatch property. Notice here, it could be Boolean, but it could be, so it means true or false. But it also has a question mark, so it could be undefined altogether. OK, so now we're trying to get what the dispatch type is, what the value for this is. So with inference, we see we extend that object that has dispatch property. And if it has that dispatch property, we'll infer what type of it is. So we start to unpack it. We're unpacking that object and looking for a specific property, dispatch, and looking for a specific type of that, and then return that type U. However, if object was not specified or it doesn't have that property of dispatch, we'll just return true, which is a default version of dispatch. OK? So here we use this conditional type with inference. And then we'll start creating our create effect function. We'll start typing it. So notice that config, right, is the second argument that we pass. We say it's a partial of effect config. This is the effect config that could have a dispatch property. And we start to unwrap it with our dispatch type that we wrote right now into the T. And then we say, OK, after we unpacked that config and pulled out that value for the dispatch, is it false or is it true? If it's false, then we'll set the return type of the observable of unknown. Otherwise, it will be observable of action. And we'll set the return type to that. And again, this is a little bit simplified version, but it basically gets all the checkboxes there. OK, so now let's look how it actually works. So now, our create effect, we pass in, for example, this actions as a first argument, and say it maps to something that is not an action. For example, here's some just object with some property. Now, we're using TypeScript as our friend, and it really helps us in compile time. And even IDE starts complaining that, hey, whatever you're returning there is not an observable of action, which is great, right? And now, say we want to dispatch false. So we pass the second argument and say, OK, dispatch false. So we don't need to redispatch whatever you return. As long as it's an observable, we're good. And look, here, TypeScript doesn't complain. And this is what actually I think Lance ran into. When you pass dispatch false, it doesn't complain. But when you dispatch true, or don't pass anything at all, it catches all those bugs, which I guess something that triggered that tweet. So this was a create effect. Let's look into more. All right. So we have a create action. This is a special function that helps us create actions. What is an action? Action is an object, basically, in a nutshell, that has a type of string. We went a little bit further, and we typed that action. We said, OK, we need a type action, and that T has to extend that string, and it will be a read-only type. OK. Next, we have something that's called a creator. Creator is a function. Again, this is very oversimplified, but basically it's a function that takes any arguments and returns some kind of object. And if you were using NgRx before version 8, you might remember how hard it was to connect the dots where the actions are created, because we used to use the class-based ones. So we were newing those classes where we were dispatching those actions. And when we were listening for those actions, we were using strings of those types, or enums. So be it an effect or a reducer, we were trying to catch those strings. So now trying to find where that action is dispatched and where it's used was kind of hard, because you had to search by strings to find where it's used, and to search by class name where it was dispatched. So it's very hard to find them in the code. Now we're trying to combine those two things together. OK, so one thing, again, back to this one. Typed action is an object with a type property. Creator is a function. Right? So object and function, right? Two different things. Right? Wrong. Action creator, something that createAction function returns, is something that is both a function and an object with a type property. All right. This just shows how crazy, dynamic, and interesting JavaScript is. But TypeScript actually allows us to type it. Let that sink for a second. OK, so createAction returns something that's a function. At the same time, it returns something that's an object that has a type property. All right, how cool is that? And we can do that. That means that whatever that createAction returns, we can call as a function and use as a property. Let's see in examples. And now searching for those actions becomes really easy, because they just use the same symbol that createAction returns. So for example, we need to find where add book success action is both created and which is where it's dispatched, and where it's consumed. Let's look at it. So here it's created with the createAction function. And so it's assigned to a variable, add book success. OK, here you see we're calling that object. So we're using it as a function. It creates the action. Add book success function, and we pass in the book into it. But then in the reducer and the effect, we use it as, without the function, we're reading the type property of it. We're just passing it as an object as well. So now looking for where your action is created and where it's consumed becomes very easy. And we were really iterating over towards this, but this is the createAction, something that Nicholas Jameson came up with. He's part of the RxJS team. And it was interesting, because I was trying to find a solution. We opened the issue on GitHub, was trying to use classes still and iterating over. And where's Brendan? Yeah, we were going over and like, Brendan, let's do this, maybe this. And we had fewer discussions. And then I talked to Nicholas, like, hey, Nicholas, we're trying to solve this problem. He's like, oh, I solved it a year ago. I'm like, oh, OK, cool. So he showed me a solution, and we ended up adopting most of it for the action creators, which was really cool. OK. So now createAction, as I just told you, that it's using inside that specific property of type. But in our action, we can also pass additional properties, something that we call the payload. And at some point, somebody passed an object with a property of type. But we were using type internally already, right? This is part of the action that we want. Somebody by accident passed it in, but they didn't realize that, and they overrode that property. So we now need to disallow that property. In props, which is the special helper function, we want to allow you to pass any object with any property except for the type. So how do we do that? All right, let's look at it. So first, I created a string, saying type property is not allowed in action creators, trying to be informative, so if somebody runs into it. And then I create a type out of it, right, which is a type of. So it's a specific, it's not a string anymore, it's a specific string. And then I use, again, the same trick with unwrapping the properties. So I say if, I create a special type, disallow type property. And I say if that T extends object that has a type property of any type, doesn't matter, but it has a type property, then return me that message. Otherwise, just give me that T back. And now if somebody is trying to pass an object with that type property, they'll get the following error message right away in their IDE. Argument of type property is not allowed in action creators, is not assignable to parameter, whatever. So hopefully that gives enough signal and stops some kind of dirty errors that come with a lot of debugging and stuff like that. All right, so that was a few things, right? We've seen create a fact that can act differently and return different types based on one of the argument's properties. Second thing we looked at was how you can have something that's both a function and an object with some properties. And third one is how we can even further fine-tune our library for something if we, for example, one of the properties we don't allow. So those are three things that were quite interesting for me, at least, in the TypeScript and JavaScript world. All right, thank you so much.